So welcome back. This is Dr. Chiranjeevi Manike, Professor in Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. As part of data deep learning video lecture series, the second lecture, here we are going to discuss mainly the differences between the deep learning and machine learning. So most of the students may have the confusion, what is the major difference between the deep learning and the machine learning. So in this lecture, we are going to cover mainly the similarities. What are the similarities between the deep learning and machine learning? And what are the limitations of machine learning leads to the evolution of a deep learning. And then we'll see the major differences between the deep learning and the machine learning. So if you look at the similarities, mainly there are many different similarities. We would classify into like the first thing, artificial intelligence techniques, both machine learning and deep learning. As we already discussed in the previous lecture, the artificial intelligence and then machine learning is a subset of artificial intelligence, and then deep learning is a subset of a machine learning. So both deep learning and machine learning are the artificial intelligence techniques. Next, it requires the statistical basis both in machine learning and deep learning, mainly the data scientists. So they need to have the knowledge on this statistical basis, because in both machine learning and deep learning, we implement different techniques related to the regression, decision trees, etc. So the statistical basis is very much important. So we use the statistical concepts to understand mainly the theoretical background, the theoretical concepts of machine learning and deep learning algorithms. Next, the large data sets. This is another similarities that is a significant when we talking about a machine learning and deep learning, the large data sets. So both, as we discussed in the previous lecture, in order to improve the performance of a deep learning or a machine learning model, so large data sets are required so that the accuracy would be more. So that means in both the machine learning and deep learning models are allowed to see all the dimensions of the data. So next similarity is wide ranging and various applications. Both the deep learning and the machine learning being used in various industries and applications. So there are many applications like chatbots, NLP, natural language processing techniques are used in chatbots, and face recognition, object image captioning. There are many applications in various organizations. Next, computational power requirement. That is another thing where the researchers will understand mainly why we need that is the computational power requirements. So both deep learning and machine learning requires the more computational power in order to process the huge volumes of data, that is mainly the training and running the models. But the deep learning requires a little more computational power than the machine learning. Next, gradual improvement. So that means to improve the performance of deep learning and machine learning, so we have to keep on adding the data sets. The more the data, the more accuracy, or the models will be allowed to see all the dimensions of the data. So the accuracy obviously would be improved in both machine learning and deep learning. So these are the similarities among the deep learning and machine learning. Next, the limitations. What are the limitations leads to the evolution of a deep learning? So machine learning, in the previous lecture we already discussed the traditional machine learning approaches mainly. What are the limitations? So one of the major limitation with the traditional machine learning approaches is the human interaction involvement. The huge or significant human interaction required in this machine learning. So where the human interaction is required in this machine learning, So mainly to identify the features, like suppose if the task is to classify the given image is a cat or a rat or a dog, and in this we have to identify, the humans need to identify or label the data sets. Like suppose if you are working on a tomato leaf disease data sets, so we have to collect, like suppose we have to collect the data set that is tomato leaf, or the leaves, those are affected by the different diseases, like mainly the virus, fungus, etc. So then that data need to be pre-processed. That is one thing. That means to remove the unwanted background or anything which is not useful or which influence the model performance. So that is a one thing, and the another thing is a labeling part. So like in the labeling part, the manual labeling, and also we could use some algorithms to label it. So obviously algorithms, labeling with algorithms would be more effective than the human labeling. That means we can just check the severity or the type of, whether it is what kind of virus affected, so we could label it. So that's why the machine learning models, mainly in a feature extraction labeling part, requires a significant human intervention in this machine learning. So that is one of the major limitations of machine learning. Next, another thing is, though these two, machine learning and deep learning, AI, they were there like 60 years back also, 1960s. But why the demand for all these technologies increased now? Why we are talking more about, and why many companies have been adopting and using or developing the technologies on this deep learning, machine learning, artificial intelligence. So when these technologies been introduced like 1960s or 60 years back, so then there were no enough data set. That is one thing. And another thing is, there is no such computational resources. One is the data. There is no enough data, that is to train the models, both the machine learning and deep learning. That is one limitation. Why these technologies were not popular when they were introduced like long back, 60 years back. And the second thing is the storage limitations. The storage cost is also more those days. And the third one, very, very important thing, is the computational resources. Nowadays, we are using suppose if our personal computer, laptop are not able to process, or no, it's not enough to train the deep learning or machine learning models. So we are going to hire the services like cloud services, mainly GPUs. Few institutes or organizations, they have been they are purchasing the GPUs, graphical processing units, to process this high complex, high data intensive tasks. So these are the two major limitations that leads to the development of deep learning. Next, another key differences. What are the major differences? So where we can apply this machine learning, where we apply this deep learning, what kind of problems could be solved using a deep learning, or what kind of problems could be solved using a machine learning, and also what are the different problem solving approaches we use in both deep learning and machine learning, that will be discussed here. So intended use cases, mainly, so which problem could be solved using the deep learning or machine learnings. So mainly, like the data set, if you look at the data which is available in the digital universe, the most of the data is 80%, I would say 80% is unstructured data. So most of the machine learning algorithms could be applied to the structured data. So structured data. So but whereas unstructured data, if you could take examples of image, image data, audio, video. Like these are all the unstructured data. So to process this data, process in the sense to build the models. So to build the models, so machine learning will not be appropriate for building the models over this kind of unstructured data. So because the accuracy so may not be extracted, or the features may not be extracted with the help of this machine learning. So that's why so most of the deep learning models would be applied to the unstructured data like image, audio, video, and even like natural language processing, NLP, text, that is to process the large volumes of text data. So almost all natural language processing applications related to this NLPs are implemented using the deep learning models like LSTM, generative models, etc. Large language models. Next, the problem solving approach. So how the problems would be solved using this deep learning and machine learning. So there are like different approaches we follow in both machine learning and deep learning. Like mainly if you look at the machine learning, the deep learnings, the deep learnings are implemented based on how the information would be processed in our human brains. So here each node would be represented as a neurons, and the information is propagated from that is in a forward direction. And if any error is calculated, and that error will be forwarded back, that is to adjust the weights, that will be discussed in detail in the coming lectures. Next, another key difference between the deep learning and machine learning is the training methods. And if you look at the machine learning, what are the different training methods we use? Like supervised machine learning and supervised learning, unsupervised learning, semi-supervised learning, like semi-supervised learning, and also the reinforcement learning. These are the four major training methods we use in machine learning. And we could also use other training methods in machine learning like transfer learning, semi-supervised learning approaches. And coming to the deep learning, there are like convolutional neural networks, recurrent neural networks, so generative adversarial networks, and auto encoders. So these are the different types of training methods used in both machine learning as well as deep learning. Next, the human involvement, as we discussed. If you exclude the pre-processing part, and the remaining thing is that is to identify the features and the labeling, etc. So that is the much in both machine learning and deep learning, the human involvement is required, but the objective of machine learning is to minimize the human involvement, so that the human involvement in the deep learning is very less compared to the machine learning. Next, another important thing that is difference between the deep learning and machine learning in terms of infrastructure requirement. So machine learning models would requires very less infrastructure, less in the sense like the complexity of these models are not much, but compared to the deep learning models, where the deep learning models are built based on the neurons, artificial neurons. So like suppose if you want to process an image, like suppose if the image size is around 200 and 200, that means 200 by 200 pixel size, the dimension of this image. So 200 times 200 number of neurons are required in the input layer. So there will be billions of parameters need to be tuned, and if the complexity of the deep learning model increases, the parameters and the computational resources would require more. So that's why most of the deep learning models would not be run on a normal machines or a CPUs. So most of the deep learning models requires the extensive computational resources like GPUs, graphical processing units. Even like suppose if you want to run a deep learning model which is based on the NLP or image processing related applications, and if you want to run your code or build the models, and most of you might use the Google Colab. So there, this by default they will allocate the GPUs to process this kind of a task. So the infrastructure requirement for the deep learning is comparatively more than this machine learning. So here I just summarize this. So these deep learning models demand more storage and computational power than the ML models, because the computational this storage also another important thing than the also computational, along with the computational power. So machine learning data and models can run on a single instance or a server cluster. Single clusters are enough to run the machine learning models, whereas deep learning models often require a high performance clusters and other substantial infrastructures. Like as I said, GPUs, those are mainly like a parallel. These are designed to process the data in parallel. So it's a cluster of different many servers. So the infrastructure requirement for deep learning solutions can result in significantly higher cost than the machine learning. So on-site infrastructure may not be practical or cost effective for running the deep learning solutions. So these are the major differences between the deep learning and machine learning. So before I just close the session, let me summarize what we discussed in this. So here we discussed mainly the differences between the deep learning and machine learning. Here we discussed mainly the similarities among the deep learning and machine learning, and another thing is the limitations of machine learning that leads to the development of or evolution of deep learning models. And the last we discussed mainly the differences between the machine learning and deep learning. So thank you for watching.